How median barriers improve highway safety. Welcome back to Blueprint to Reality, where we dive into the design, structure, and strategy behind the world's most essential infrastructure. Today's topic is one of those silent sentinels of safety we often overlook while driving: median barriers. These seemingly simple dividers between lanes of opposing traffic play a crucial role in saving lives on highways. But how exactly do they work? Why are they needed? And what makes them so effective? Let's find out. What are median barriers? Median barriers are physical dividers placed in the center of roads and highways to separate opposing traffic flows. They can be made from concrete, steel, cable wires, or even earth berms, and are usually seen in the center of multi-lane highways. Their job may seem basic, to keep vehicles in their lanes, but their impact is anything but simple. These structures are at the front line of highway safety, especially on roads where vehicles travel at high speeds in opposite directions. The purpose: preventing crossover collisions. One of the most dangerous accidents on highways is the crossover crash, when a vehicle veers out of its lane, crosses the median, and slams into oncoming traffic. These head-on collisions are often fatal or severely injurious due to the combined speed of both vehicles. Median barriers are specifically designed to prevent or reduce the severity of such collisions. They act as a physical shield, absorbing the energy of the crash or redirecting the vehicle back into its lane. Without these barriers, a simple steering error, drowsiness, or slippery road condition could result in catastrophic accidents. Types of median barriers. Median barriers come in three major types, each designed for specific road conditions, traffic speeds, and budgets. Rigid barriers. Most commonly made of reinforced concrete, these barriers do not deform when struck. The popular Jersey barrier falls in this category. They work by redirecting the vehicle along the barrier, keeping it from crossing over while minimizing vehicle rollovers. Semi-rigid barriers. These include guardrails, typically made of steel and mounted on posts. They offer some flexibility, bending slightly under impact to absorb energy, but still prevent the vehicle from breaching the median. Flexible barriers. These are cable barriers, 3 or 4 tension steel cables held in place by posts. They absorb crash energy by deflecting significantly, gently slowing the vehicle while preventing a crossover. Though visually less intimidating, they are very effective in open medians and are often used where budget or landscape considerations limit concrete construction. Engineering behind their effectiveness. The effectiveness of median barriers lies in physics and design. Each type is engineered with specific goals: to control the trajectory of an out-of-control vehicle, reduce the severity of a crash, and protect both the erring driver and the oncoming traffic. For instance, concrete barriers are tapered at the base, so the tire rides up slightly on impact. This helps redirect the vehicle's motion rather than causing it to flip or rebound into traffic. Cable barriers work like a giant shock absorber, distributing the force across posts and cables to dissipate energy safely. Where median barriers are most needed. Not every road has or needs a median barrier, but certain conditions demand them. High-speed roads, expressways, freeways, and divided highways where vehicles travel at 80 kilometers per hour or more. Narrow medians. When the space between opposing traffic is limited, the chance of a crossover is higher. Crash history. Locations with a record of median crossovers or head-on crashes often get prioritized for barriers. Heavy traffic volumes. The more vehicles on the road, the higher the risk of one losing control and crossing over. Even in rural areas, long stretches of highway with low lighting or hilly terrain can benefit from median barriers to compensate for limited visibility or road geometry. Real-world impact and statistics. The statistics speak volumes. In countries that implemented cable median barriers across major highways, crossover crashes dropped by up to 90%. In the United States, the Federal Highway Administration has documented significant reductions in fatal and injury crashes after the installation of median barriers. They are especially life-saving on roads where traffic moves at high speeds in both directions without much space in between. And as urban areas expand and more roads are upgraded to handle fast-moving traffic, the demand for these barriers continues to grow. Design challenges and considerations. Designing median barriers isn't just about placing concrete in the middle of the road. Engineers have to consider median width, slope and drainage, snow removal and maintenance, visibility and aesthetics, cost versus performance trade-offs. Additionally, emergency vehicle access and pedestrian crossings must be integrated thoughtfully. On urban expressways, median barriers may even include landscaping or noise reduction elements, blending safety with function and form. Future innovations in barrier technology. The future of highway safety includes smart barriers, those embedded with sensors to detect impacts, collect data, or even trigger warning systems. Some prototypes are exploring modular designs that can be quickly replaced after a crash. There's also ongoing research into recyclable and eco-friendly materials, reducing the carbon footprint of barrier construction. At the same time, barriers are being integrated with lighting, solar panels, and noise reduction panels, turning them into multi-purpose infrastructure. As we head towards smarter, faster, and more connected transportation systems, median barriers will continue to be a cornerstone of road safety, quietly standing guard, keeping chaos at bay. From a driver's perspective, they're just part of the road. But from an engineer's perspective, they're a masterclass in design, safety, and human impact reduction. Thank you for joining us on Blueprint to Reality. We'll see you in the next video, where we continue to reveal the structures that shape our world.